Hello, I'm Shreya Chatterjee. I'm a PhD student at the University of Kansas. The title of my poster is Assessing Future Nitrate Yield in the Eastern Kansas River Basin, Implications of Climate Variability. Excess nitrate levels in water are a common water quality issue, often leading to problems like eutrophication, where too much nutrients promote excessive algae growth in lakes, rivers, and coastal water. Nitrate concentration in streams varies over space and time due to various influences such as climate, land use, and fertilizer application. And understanding these influences is crucial to managing water quality. By using statistical models, we can better understand how agricultural practices and climate have affected nitrate levels in the past from 1998 to 2022 and how they may continue to influence these levels in the future, projecting from 2025 to 2099. This information can help guide water management decisions and potentially improve water quality outcomes. The main research questions we are trying to answer are what are the main factors influencing the amount of nitrate export in the Kansas River and how future climate scenarios might affect the nitrate yield in the Eastern Kansas River Basin. Our study area is the Eastern Kansas River Basin, a watershed of the Kansas River between its beginning and the confluence of the Smoky Hill and Republican River at Junction City and its terminus at the confluence with Missouri River in Kansas City. We retrieved the nitrate concentration data and daily discharge data of 3 locations in the EKSRB, DeSoto, Lecompton, and Wamego from NVIS and Storage repository. Since the data was temporally very inconsistent and sparse, we used the weighted regression on time, discharge, and season model to calculate a daily estimate of nitrate flux to fill the gaps in the available data. We then conducted a multilinear regression analysis to explore how different variables like precipitation, temperature, SPEI, weather whiplash event, land use, nutrient use, and irrigation water use might influence nitrate yield. Finally, we obtained projected meteorological data from 2025 to 2029 from an ensemble of 5 general circulation models to evaluate how they affect nitrate export in the future under RCP 4.5 and RCP 8.5 emission scenarios. We initially tested the multilinear regression model with all the predictor variables, then found that only the climate variables like precipitation, temperature, SPEI, and weather whiplash events are significant across all 3 locations. We then refined the model by retaining only the climate variables which are temporally dynamic. The MLR model has shown reasonable predictive accuracy across all the 3 locations, with Lecompton having the highest performance, followed by Wamego and then DeSoto. However, in certain years like 1999 and 2019, the model's predictions are significantly deviated from the observed values. These discrepancies align with years of extreme high annual flow, suggesting that extreme flow conditions might be impacting the model's ability to accurately predict nitrate yield during those periods. We then executed the regression model with projected meteorological data and found that predicted yield values are generally higher than historic yield. An upward trend was observed in predicted yield, especially from 2075 to 2099 under both RCP 4.5 and RCP 8.5 emission scenarios. With RCP 8.5, which is the high emission scenario, the model predicts higher yield compared to RCP 4.5. Also, the MLR model struggled to accurately capture yield in years with high total annual flow, suggesting that it may be under-predicting yield during periods of exceptionally high rainfall. In both historical and future scenarios, weather whiplash has been included as a key factor. However, predicting future whiplash has uncertainties which may arise due to the inherent variability in general circulation model climate predictions. This aspect could be further explored to better understand how these uncertainties might impact our prediction and improve future scenario accuracy. Thank you.